Okay, good morning, everybody. Welcome to the first session of the GSE storage stream. I'll just wait a moment for a few more people to join. Okay. Our speaker this morning will be Tim Redding from Luminex Software. I know Tim pretty well, and I'm sure that we're going to get an illuminating presentation for our first session. What we'll do regarding questions is please open a chat window on your Zoom session. There's a chat icon at the bottom of the screen. Zoom can sometimes be a bit odd depending on whether you've got the session full screen or not. Ask your questions in the chat session, and we'll get to them at the end, so as not to break up the flow of the session. Just a reminder, you've probably been told already when you're joining that the session's been recorded, and the sessions will be made available to GSE members later, I believe on a platform called Vimeo. Right, with that, I'd like to hand over to Tim if you're ready to go. Tim?
Yeah, I think I'm ready to go. Morning, everyone. So I'm Tim Redding, and I'm an EMEA account manager for Luminex Software. So Luminex Software, we've been delivering and developing IBM mainframe virtual tape solutions for over 25 years now. So as you can imagine, my approach for this discussion on data protection models is based around requirements for virtual tape. Luminex has also been attending GSE for years and has discussed the Luminex product. I thought I'd do something a little different this year. And I would select a use case to talk through from the examples we have around the world. It's a specific use case. It's based around a core premise, and it's a sample of a use case that we're seeing at a number of customers. And then I've also developed it along the lines that those customers have done. So it's based around a use case, but just to put it into context, I will give an outline of the basics of our virtual tape product, just to give the discussion a bit of context. So for those of you who know Luminex, it's a short intro. For those of you it's new, it's an introduction to the product. Now, I've not seen a mainframe environment without a tape element, and nearly all of these are virtual tape in one form or another. Luminex, our implementation of a virtual tape emulation platform is the Luminex Channel Gateway, the CGX. Our CGX control unit software emulates 3490 and 3590 mainframe tape drives, of course. Connection to the hosts over 2 FICON channels per CGX. We have a 32 gig card in there at the moment. Of course, it'll be running at 16. Hardware compression is in flight. We include a software failover capability. We exploit the way we handle the tape volumes to get the maximum out of the compression. And of course, as per the other products on the market, the CGX platform includes replication services for offsite copies, capabilities around DR, and monitoring, etc. A number of years ago, it used to be a monolithic software platform, but a number of years ago, it was re-engineered and turned into a more modular design. So that reference to modular design refers mainly to the software capabilities. And it means that we can be very agile around developing this product, and quick and easy to develop those services. So that's the main virtual tape platform, very briefly. On the mainframes, we are very light implementation on the mainframe. So ZOS, VM, VSE systems, most virtual tape environments need some kind of allocation steering and a scratch synchronization utility. They're the bare bones. We have our own allocation steering, but the simplicity of SMS means that the majority of our implementations are based around SMS managed tape. So that would leave potentially as little as the scratch sync util. We have plugins for all the major tape management systems, but we've also written a few for the few homegrown versions that are out there. In terms of managing the CGX, most of the virtual tape environments are managed by managing virtual tape drives, channels, so standard IBM commands. Management of the CGX itself, we have a GUI on the CGX. You can log on to the CGX and you can manage the CGX in the entire estate from the single GUI. But we have an optional mainframe component to manage some of the CGX functionality via command line or through batch if you wanted. On the storage side, we are largely agnostic to the storage. We have our own storage platform, which we can provide with CGX for an integrated service. But we've also certified models from all the major vendors for storage, and within that, fiber channel or NFS attach, plus a capability for cloud services, so an S3 connector. In terms of the hardware, we are developing the hardware platform all the time. Every so often we roll them up into a version. The latest version is our G10 platform. It was introduced earlier this year. As I mentioned, we've put 32 gig Ficon cards in there, running at 16 gig. We are seeing some performance improvements by using the 32 gig Ficon cards. We've not benchmarked it, but I'm looking forward to that. The compression algorithms, it's a hardware compression card, but we control the algorithms on it. And we upgraded those end of last year. We've not benchmarked it. It's very subjective in the field. It's always typically 4:1 compression. But for the environments that we've upgraded and installed recently, we are seeing up to 5 or 6:1 on top of what we would normally see as 4:1. We certified it for 25 gig Ethernet earlier this year. And it's a fairly compact unit as a hardware platform. But the main element of the CGX is the software. So this is where all the work is done for a virtual tape environment. I mentioned that replication services, so we have a synchronous and an asynchronous model, not mutually exclusive. And of course, that brings in replication monitoring and management services for DR invocation and DR testing, etc. Encryption is a given. It's almost standard for us to implement with encryption. We have a key management software package that we install on the servers, but we can also integrate with external key managers where required. I'll call out MVT HSM because that's one of those software packages that we've developed and can install optionally on the CGX. And that's a way of exporting your reclaim for spare space out of your HSM environments for tape to the CGX. So we can actually reclaim HSM space out of the tape storage between the CGX and the storage without impacting the hosts. Bottom right, reference to professional services. So by default, we offer an end-to-end implementation service for the products. But we also provide tape migration as a service. So it's fairly unique. If you wish to take us up on the option of tape migration, and this is from an existing tape platform to a Luminex platform, we would provision you with a tailored software package. On install, we'd validate the installation of it, and then the control of the initiation of the service and how fast it runs, whether you wish to pause it at any instance, that sits with you. But technically, once you've initiated it, you could just leave it alone and wait for a message to pop up X weeks later, depending on the size of your environment, just to say, I have finished migrating. So it's a fairly unique option. And it's based around cloning, so it carries forward your tape catalog. Bottom left, I've got reference to our MDI software package. So this is a software component that we can install and use in parallel to the virtual tape software. And it enables you to move data exchange services from typically what is IP-based to FICO. So I'm not going to go into that at all today. Got a session on Thursday to talk around that. And that is really all I wanted to mention in terms of the channel gateway. So it's just to put it into context for the follow-on discussion, because the rest of it is based around a use case. So if I open the use case with a sample customer environment, and I'm going to start with the customer's core environment. So I'm going to start with a customer's environment as a GDPS HA model. Active. The model doesn't change if it's classed as an active, passive, etc. But I'm going to put it in as active because it's more interesting. This, of course, brings in disk mirroring, hyperswap, potentially separate GDPS invocation groups, hyperswap groups, multi-systems within that. So all the fantastic things you can do with MVS systems these days. And of course, your typical customer is looking for a tape service to complement this kind of implementation. So typically a synchronous replication service. Now for us, our synchronous tape service is based around the Luminex Synchronous Tape Matrix, the STM. It's a very resilient architecture. It's got the capability to instantly adjust to service outages and automatically adjust to those service outages without interruption. The objective is to make sure that data is always available for I/O. It's also self-recovering. So no downtime from failover or restore processes. It runs fully active. So it's a bidirectional replication service. I've got a bit more on the next slide on that, but it means that all the components in the solution, in the implementation, contribute to day-to-day operations. So it's not just during failover events. Because of the architecture and the way the architecture is set up, it also means that for us, it's a straightforward implementation into environments like a GDPS HA active service. Technically, it does not need any host scripting or policies to implement and service the requirements of that sort of environment. Highly scalable, so no technical limits on throughput or capacity. It's based on your storage. So that's the core model that we have for our synchronous tape service. Now, if I put that over the customer environment, and this is highly schematic, so there's a few switches missing from the diagram, just assume they're there, but the principles of the data flow are there. So I'm going to put it in as a fairly basic 2x2 synchronous tape matrix. In this configuration, you're looking at around 1.2 gigasecond sustained per site. And that for us is scalable by node. So it's a linear scalability as you add CGX to the configuration. Of course, your storage is scalable by the capability of your storage. If you notice, it's not actually replication. So we're not replicating CGX to CGX. The implementation we use is a dual write to storage. So as you open a tape, we open a connection to the storage at both sites, and we write the data at block level, synchronous with the write from the hosts to the storage at each site. So we're managing at a FALSA level, but we're committing to storage at block level, synchronous with the write. Because of that, we can write into the CGX at either site in parallel from either system, and it will provide the data protection across both storage platforms. So this is a full bidirectional data protection model. And that's the element that gives us the capability for the unscripted dynamic failover capability. So full integration into the GDPS HA model for the mainframe systems. Now, what we're seeing is our customers with these sorts of implementations, looking at them in a wider context. If it's a GDPS HA environment running active, then it's typically within a metro area. So I think the maximum is 30 miles at the moment. And within those sorts of distances, customers are seeing potential single points of failure on external infrastructure. So that's either external infrastructure or even geographical events. So one of the common requests we get is for the extension of the environment to include a remote DR site environment. As a remote environment, it's typically a passive environment with asynchronous replication for the mainframe primary disk, and of course, parallel DR testing capability out of it. Tape is different to the transactional nature of disk. So even on a remote, on a more remote data center, we could extend our synchronous tape matrix across the 3 sites. We have implemented a very large one of these just recently, and it's working very well. And in this basis, you use the CGX at the prime sites. So all the CGX at the prime sites contribute to creating the additional 3rd copy synchronously with the write from the hosts. But for this particular discussion, and I've got a reason for it, I'm going to say that we're going to work with it a remote DR site and settle on async data protection for the tape services. But using the disk-based capability, so disk-based services for replication. So like I said, we do have our own asynchronous replication service, but we're quite comfortable working with the capabilities of preferred disk solution if they suit the solution. You lose a little visibility on the replication status at any point because it's at file system level. And also in this type of architecture, the replication source is either disk in site A or disk in site B. I'm going to put one more element into this. Used to be unusual, but not anymore. And that's for an additional requirement for a copy of a subset of the data to be specifically replicated to another location. So this is something we get asked for every so often. It can be a temporary implementation for application migrations to other sites or systems. It can be convenience of data location for the systems processing at those sites, or even for data residency requirements. So in this instance, I'm going to add it in as Luminex CGX to CGX replication to deliver that service. Now, the reason why I put the replication in at disk level for the DR site is because this came up just recently. Customer was looking at a potential disk refresh. So they have external applications which had generated drivers for a specific storage platform. And the option came up to exploit the throughput capability and capacity of the scale-out storage being proposed. Now, for a dedicated tape environment, scale-out storage is not typically what you would choose as your first option. But in this instance, the option was there to exploit that capacity. Still NFS, but it turns out to be a different vendor for this one. And when I checked it, we hadn't actually certified it against the CDX, but as it happens, the technology partner had who was looking at this for the customer had a sample in their labs. They were good enough to allow us to send them our test bench, which they set up and ran for us. I mean, the initial results were very good. It's always good when the initial setup is clean and runs straight through. But also when we took the results back to the labs, they were excellent on the performance and capability of the storage. So the test bench exercises in the style that you use for mainframe tape writes and reads. And then we also look at the resiliency of the platform, etc. So on the basis of that, we were able to actually add it to our portfolio. So as I said, we do have our own storage, but we are also supporting platforms from Hitachi Vantara, IBM EMC, NetApp, of course. I mean, we added Cohesity and Pure not so long ago. NEC HydroStore has been in there for a while, VAST. And I think we're just evaluating Cumulo K. So the storage platform is not a constraint for us. But with the refresh, it prompted the suggestion to move the replication up to CGX level. And this brought in a number of benefits for this customer. It would be asynchronous replication, but that brought in replication and monitoring at volume level. So in other words, the replication service is now more akin to the way that the mainframe hosts are actually writing the data and managing it. A couple of other benefits. By using CGX to CGX replication, we can enable it as any source, any target. So replication to the DR site comes out of site A and site B, and all the CGX in the solution to maintain the copy at the DR site, in addition to the copy at the remote site. On top of the service for the replication, of course, it allows us to exploit the capability of our own services for DR and DR testing. For the use case we're looking at with multiple GDPS environments, of course, this the capability of the push button DR is to allow disparate GDPS groups to be tested in parallel or in different times, etc. So the capabilities there within the push button DR. So that was as far as potentially we were going to develop this environment. This is not an unusual use case. We're looking at it as a stable environment. This is your dual site GDPS HA support, running active out of site A, site B. We've got an asynchronous third site DR copy with parallel DR testing, invocation capabilities out of there, plus a fourth site data subset replication. So that is our core model. But in terms of what we're seeing recently, that customers are developing this further. So I couldn't get away without mentioning cloud, could I? I've been working in virtual tape environments for quite some time, and cloud has been a tick box exercise for a while for mainframes. No matter what the requirements were in the ITT, the RFP, the solution needed to be cloud ready. But we are now seeing use cases for on or off-premise archive and the exploitation of cloud for additional extended copies, because customers are beginning to explore this for additional data protection options. Now, I've seen two particular use cases, and I'm going to go over both of them for cloud. But just to clarify something before I go into that for the use case, a bit of a digression. There are several routes to cloud. If using our CloudTAPE option with an S3 target, then you're writing a tape image to the S3 target. So this means the mainframe format for that tape image is carried forward, encryption, compression, of course, and it's stored as a mainframe tape image, and it's typically a subsequent action to the initial write. We do have a model for actually using cloud as the core storage, but I don't want to go into that today. The alternative is to use the mainframe data integration software, and passing the image through that, it strips off the tape element and it gets written as a data element to an S3 target. We have data translation options, so it's typically going in ASCII format. And for those use cases, it's based for cloud-based application use. It's either cloud-based application or external applications that use cloud as the storage. And one more digression on that. MDI is not just to get data into the cloud, it's actually multi-target. It's a multi-target utility. But to come back to the use case, the mechanics for this use case is using it as CloudTAPE. So the tape image in the cloud. And I mentioned that we're seeing use cases for both archive and additional data protection. For archive, it's typically around recovering storage out of the storage at your prime sites. If you're a tape user, you've seen this expiry curve. This is the rate at which data accumulates in any tape catalog for a mainframe. It's a very standard curve. Some are very steep, some are very shallow. That peak at the end there is any observation of, say, over 2 years, where that accumulation of data is gradually accumulating. And activity on tapes, typically all within the first 2-3 weeks, depending on the tape data site. So HSM data, of course, remains active for the duration of the data's in there. But most read is based around a certain age of data, at which point your potential archive candidates become anything older than that. So in terms of the calculations, it's around the compressed data volume. But if you're running multi-sites, it can add up. So X terabytes over N sites and potentially a single cloud copy. So as data attenuates over age, you can argue that a single copy backed up by the cloud service data protection is sufficient for that. And of course, on-premise, off-premise, public, private. For us, it's a transparent host recall. So if you have archived a tape and you want to mount it for read, it just adds CloudTAPE recovery time to the mount time for the tape. In terms of mechanics, what we're seeing is most customers using it by policy or candidate list. Some customers are classifying data on write as a cloud capable target and writing it off as Cloud Direct. But most customers are archiving off the top of the age group. And for us, for archive, when we implement it, we delete the data portion on copy into the cloud. We leave the stub back on the primary storage, but it is just the stub that the tape also label. To the host, it's transparent. If they go to mount against the stub retains metadata associated with the cloud copy, and it's recalled from there. So it just adds the recall time. It's a bit like ML2 for a tape environment, for your tape storage. But I also mentioned additional copy, and that's got slightly different mechanic. And we have implemented both on this one. Exactly the same criteria for generating additional copies. Since it's an additional copy, you can actually generate it from the DR site as well. But we did put in some extra features on CloudTAPE, and that's where this use case starts exploiting those. So we have support for multiple versions of the same tape in a cloud. And this starts bringing in the capability of applying extended retention criteria for CloudTAPE copies. So this is a retention criteria outside of what you would apply to your primary tape catalog. Because we're supporting multiple copies of the same virtual tape, it means you can start generating point-in-time CloudTAPE copy groups of tapes that have a data integrity group. And typically what you'd have to do is pin the expiry of all the tapes in that group to the longest expiry of any of them. But because you can allow the primary tape copies to expire and be rewritten in the cloud, there's multiple versions, you don't have to do that. You can actually just retain that in point-in-time copy group external to your tape catalogs. When you roll in the consideration that cloud is an air-gapped copy and a potential immutable air-gapped copy, this then further extends the data protection options for our customers. And we are seeing customers explore this now. Now that does bring me to the end of the use case we've got. So basically it's the integration with the GDPS HA model. So we're seeing GDPS HA models across a lot of the geographies we're working in. Active dynamic failover capability. And with that, customers are looking for the additional third site remote DR copy with all the requirements around DR and DR testing, etc. The data subset at the remote fourth site is typically generated by application migrations or data locations. It's not very common, but we are seeing examples of that come in now. And the use of CloudTAPE for both archive and or extended copy is beginning to creep into the implementations we're putting in. So these are the sorts of developments that customers are putting on their tape environments. And this isn't a hypothetical use case. So I've taken a little bit of license with the overall end state, but it's based on samples of data protection requirements we're meeting today, and customers are asking for. So we're seeing more recognition, and this is at all levels of the business, that resiliency models over and above the standard prime site DR site are being required, with third and even fourth site copies. Plus the use of cloud and immutable cloud-based copies. This is becoming quite a driver. So the business drivers are there, and the business drivers are there for much more flexible solutions around these data protection models, even for mainframe services. And the drivers for within that are service relocations against those more flexible business models, even regulatory drivers. So that's the sort of elements that we're looking at and trying to deliver to in the field at the moment. So as a demo of what our customers are doing, I hope this has been of interest. It would be good to hear from you if you're looking to develop these kind of models or are being asked for them. And if there's anything you think we could be looking at for you or would just find interesting, just drop me a line. That would be great. So I will hand back to Nigel at this point and just say thank you for your time.
Thank you very much, Tim. You've set the bar for future sessions quite high, not least because you've finished slightly early. So, are there any questions for Tim? If you do have questions, then place them in the chat. Or raise your hand.
Or drop me an email after the event, or etc.
Okay, I mean, if anybody wants to unmute themselves, they can now do so. So if you haven't found the chat session and you want to ask a question. No. Okay, Tim, could you go on to the next slide, please? So this is a little bit of GSE admin. This really describes the charity raffle that we're doing. We do this during the face-to-face sessions, face-to-face conferences at Whittlebury Hall, where people will come round, typically when you've had too much to drink, and extract money from you. This is the virtual form of it. So would encourage you to drop some money in if you can. GSE does match the donations, I believe, up to some fairly large amount. If we can go on to the next one, please, Tim.
You forgot to mention the prizes. So you get a raffle entry for every £1 donated.
Oh God, yes.
Yeah.
Tim, you're keeping me honest. Thank you.
And it's a nice set this year. I do approve of the prize group.
I'm glad you've been paying attention, because I've been to a million conference calls on this, and it's gone in one ear and out the other. Okay, next one. Please do submit your session feedback. The session number is 7AB, and there's the link to do it. Again, as an incentive for this, there is a session feedback prize, or probably raffle is more correct. So you're not guaranteed a prize by putting your feedback in, but you're guaranteed not to get one if you don't put your feedback in. So this helps GSE, it helps Tim. If you require evidence of continuing personal education, then the way it works with the conference is we take the feedback form as evidence that you've attended the session, and at the end of the conference, then you can go to the My GSE part of the GSE website and basically print off a certificate for continuing personal education. Okay, just double checking that there don't appear to be any questions. Still no questions. So with that, thank you very much, Tim. Enjoyed your session. I look forward to virtually seeing you at future storage sessions. There are, I think, 15 of them this year, and next one later this afternoon.
I think I'm back on Thursday, and that really is to talk about mainframe data integration, the use of mainframe data external to the mainframe platforms.
Right. Okay. With that, thank you very much indeed.